Welcome back to the course C# Advanced Language Features. I'm Philip Ekberg, and now we are going to talk in detail about events in C#. In the previous module, we used a delegate to communicate that the order processing had reached a certain state. The idea of signaling that something reached a certain state or that something happened could also be seen as publishing or racing an event. For example, you could look at a graphical user interface. This application has a button, and when you press it, you want to run some code. This application uses WPF to create its interface. But the same applies to, for example, WinForms, .NET MAUI, and Xamarin as well. It uses a delegate to allow you to reference a method that is executed when you press the button. The only part of the system that should be in charge of invoking that particular delegate is the button control itself. It would be quite odd if any code throughout the application were able to invoke the click delegate. You only want that delegate to be invoked when that actual button on the UI was pressed. One of the issues with the publicly exposed delegate that we had earlier is that anyone could invoke it, just like a normal method on that class. In some cases, that might be what you are looking for. However, when it comes to events in C#, that wouldn't be desirable. This means we have to take a slightly different approach. We are going to introduce a new keyword called event. And all of the knowledge about delegates is definitely necessary to completely understand how the events operate. When you talk about events, there are two important parts of this pattern: the publisher and the subscriber. The publisher owns the event and makes sure that anyone that's interested in this event will be notified. The subscriber can be anyone that is interested in when this event occurs. Let's start by looking at how an event is created. The idea behind an event is that it follows a very basic pattern. It all starts with the event keyword. The event keyword is followed by a delegate. While you could technically use any delegate together with the event keyword, you should not. An event will never return a value. Therefore, the delegate that it is based on will always be void. It's recommended to follow the same pattern used in .NET and as suggested by the guidelines. This means the delegate that is used together with the event keyword should be based on the event handler delegate, or the generic alternative. The event handler delegate defines two parameters: the sender and the event data. The event data is also known as the event arguments. The sender is of type object and refers to the instance of the publisher that races this event. The second parameter should use the base type event args. This class should contain the event data. This could refer to the data which caused the publisher to invoke the event handler. An event can be defined in any class, like you'd specify a field. The event handler is really just a delegate, and if you forget to add the event keyword, it will behave like you saw in the previous module. When you do add the event keyword, The compiler will know how to handle this and make sure that it's only allowed to be invoked from within the publisher. This means you could only call the invoke method on this delegate from within this class. The event keyword also generates code to expose something called add and remove, as opposed to the getters and setters you have on publicly exposed properties. This ensures that whoever is accessing this event from outside the class is only allowed to add or remove a delegate from the invocation list. We now have an event called order created. This is all that is required to create an event that anyone with a reference to an instance of this publisher can subscribe to. Let's add this event to the order processor, and the order processor is now known as the publisher of this event. It owns the order created event, and it will ensure that it is notifying the subscribers when appropriate. As you've probably gathered, there's still a couple of things that's necessary to add before this is completed. The event needs to be invoked at the appropriate time, and the subscribers, if any, need to subscribe to this event. Let's proceed to invoke this event. The pattern to follow here is to wrap the invocation in a protected virtual method. This is because it will allow subclasses to override this method. They can then act on this prior to notifying all its subscribers through the base class. If the event is called order created, it's good practice to call this method on order created. This will indicate that this method will execute when the order has been created. You can now invoke the event. This is also known as raising the event. Since the order created event is really just a delegate, when you invoke this, it will sequentially invoke all the subscribers that we have method references to. Under the hood, this all builds on the delegates that you learned about in the previous module. When you invoke this, use the null conditional operator. This will ensure that it makes a local copy of the reference and then performs the null check on that locally stored reference, which it then uses to invoke it. This is to avoid a raise condition. The first parameter is a reference to the publisher. This is the instance of the class that publishes it. This is also known as the sender. The second parameter is the event arguments, also known as the event data. We'll cover event data in the next clip, so for now, we can use event args.empty to indicate that we do not wish to pass any particular data in regards to this event. Because this method is protected and virtual, a derived class could now override this. It could be useful in cases where you want to modify or extend the event data before the event is being published. The subclass should always call the base class to ensure that the event is properly published. In fact, the derived subclass couldn't call invoke on the event even if it so liked to. The only class that is allowed to invoke the event is the class that owns it. That's why you'd have to call base.onOrderCreated to ensure that the event is being raised. Now that we have a way to invoke the event, it's a good time to call the method onOrderCreated at an appropriate time. Let's assume that after the call to initialize, the order has been formally created in the system. After the call to initialize, we'll call our virtual method onOrderCreated. If there's a subclass that overrides this, its method will be the one that's executed. This provides further extensibility to our system. Everything inside the order processor is now set up in accordance with the guidelines. We have an event that uses the event handler delegate, which specifies the sender and event args parameters. An event is always going to be void. There should never be any value expected to be returned from an event. It's simply a publish and subscribe pattern. The publisher should never care about what the subscriber does with the event and its event data.